Um, can anyone hear me? Wait, yeah, I just got some playback. I think it should be fine. Okay. Should be good. Gotta get rid of that, and put this in. Okay. Yes, looks like fine. This has nothing in it. Okay. All right. Cool. Okay, so there are a few things I want to do. First off, first thing first, is it lit the burns here? So first things first, let me get this. Hmm. Cursive. Huh. What was this say, actually? Uh, this is Hasushi, Watashi wa. I guess I'm assuming. Okay, that's one for that. Okay. It probably doesn't have to look like this, right? This looks kind of bad. Yeah, there's a themed dialogue option. Let's look at both of them, I guess. Okay. F the hell. Alright, let's see. Yeah, this one all. It uses crossfit by default. Okay, that's great. Is it great? There it is. Okay, great F. Okay, probably copy. Yep, there. Does it install crossfit on its own? I sure hope it does. Premium TUI. Right. Right. No, I'm sure everything is for punctuation. Cool. No. Cross term. That. Okay. I will go. Oh, that. Right. Hmm. Documentation demo. cross-term Permian. Right. There. Okay. Again. Oh, here it is. Done it. Oh. All right. There are a few things I want to do. One of them is Nick. What can I do? Tab 1, tab 2. Do I click 1, 2, 3? Oh, no, arrow keys. This is cross term. We got them colors. Reset black, red. Yeah, there's quite a bit of colors. This is a paragraph with several lines. You can change your text all the way you want. For example, under the rainbow. I can automatically wrap your text. One more thing is it should display Unicode characters. Data 1, data 2. Can I click on this one? Wait, no, I can't even highlight it. What if I go in here? Does this mean it's constantly updating if I scroll up? No, it's not. Same thing. Okay. I have no idea what this is supposed to be. I can click tab, I can use arrow keys, click any keys, except for left and right. Failure here. Click. Alright. What checker is okay. The UI code is in the application state is in. And just been turning out demo about this. Hieroglyphs in this. I think the colors are pretty nice. Like the world map, right? Yes. Okay. I want to look at app and UI. App, UI. The top is kind of ugly, but whatever. Okay. Just real quick. The rusty crab. Present story documentation. Version requirement. Git UI. Rust CLI. Sandwich. GPG. What's this supposed to be? Yet another graph cross graph. Fancy. Block gauge. Chart campus. With flying point cloud map. Okay. I'll come back to it later. Alright, let's see. Okay, documentation is. Alright, I reset my cookies and everything, so everything's kind of black. There you go. That's better. This one. Auto hide content, system team. Done. Online numbers located. Thank you. Object I can take get back now. Alright, cool. Let's see, cross-term 2.2 features, default features false. This is the toml file, right? Wait, from toml, right? I version that. Version. Yeah, I guess it's fine. Redo, redo. Excuse me. Processor 0.22 and 2. I hope it works. Okay. Yeah, it works just fine. Alright. Didn't mean to do that. Cool. Well, let's do something simple then. Terminal. Use TUI backend processor and TUI backend processor. Okay, last term that in Control O? Yeah, Control O. Oh, wait, is this the one that has stuff in it? Termian. This is Termian. This is. Oh. Start from then. Okay. So go into raw mode and it makes the widget. So use UI widgets. What is it? It's something called widget block and orders. UI layout and string. Then we got it back and we got the terminal. And then we gotta do raw mode. This. Processor. There you go. Enable, disable raw mode. Can move this somewhere. Oh, that's fine. Okay. Can move view there too. All right. Great. Okay, let's say it has termine into raw mode. Where is into raw mode then? Ah, okay, you just want to call into raw mode. Okay. So in here, use cross term from null. Did I spell that right? Yeah. Enable raw mode. Disable raw mode. Right. Enable raw mode. There we go. So now I've got to call enable raw mode. Let's see, enable raw mode. Raw mode section, please have a look at it. Right, I got it. And raw mode and will not be forwarded. You try instead. Right, so I just called them. Prep raw mode. Enable raw mode. Oh, I just called them. And enable raw mode. Got it. Yeah, that's it. So you turn on raw mode right at the start, you left backend, then terminal draw F finds fault. If render widget size that. Alright. Gotta go deal with some stuff real quick. Hold on. Okay. Guess I'll be done with that. Okay, so I'm gonna turn that back off. Alright, sweet. Now, let's run it. And it just made a box. Yeah, it's pretty much just box. What did I not use then? I didn't use disable raw mode layout image. Okay. Let's see. When I last tried this out by just shoving it on top of Hector. Hold on. By just shoving it on top of Hector, what happened was this one, yep. Let me run it again. Right. So what happened was, yeah. So there's this stuff over here, right? But because the way Hector does things by constantly reprinting stuff like over it, so you could see the borders, but unfortunately, like if there's text, right, the text would just cover up everything else. Why I stopped using it. Is it still in the YAML file? Yeah, it was. Yeah, it was. Alright, cool. So what do I want to do next? Yes, so try and hijack the text border thing. But first I need to figure out how to print stuff out normally in the first place. Alright, so I look at how to print stuff. There we go. Okay. Basing on an object, you may see below examples. Build a pattern. And I got to build a pattern. Let's paste. Yeah. Cool. So this compiling. Yeah, I just straight up get rid of it. First block, second block. So chunks, margin 1, constraints direction vertical. So split it in by f size, which what f is. And that block equals title block 2. Borders all block default dot title. Title, oh wait, PC's a bit running low on battery. F render widget block followed by chunks. And you gotta put 0 inside your Y. Press split. Is split part or for a standard library or something? Yes, it is charging. Yeah, there's split in here. This is split string. This returns result. Next one, okay. Constraints, you're gonna split it by f size. So I gotta figure out what draw is for draw. Do that. Take this part. And F is something called a completer frame. Well, resolve. Hmm. Oh. Oh. Excuse me. Six. Sleeping. Let's see. We're gonna put F, which is an F and ones. An F and one. I have no idea what this is. Okay. So this draws. Is it in this? Yes. The wrapper function around category are solving was split given area into small one based on preferred widths or height in and the direction. Right, I guess first we gotta mess around with the example first. So if direction vertical, what else you have? Direction vertical. Direction horizontal. Okay, should have seen that coming. Cargo RQ. QR. No, I need it to be cargo R Q. No, I need it to be silent though. Cargo help one. Oh. That's getting kind of annoying. Display options. Cargo run options. Cargo run queue. Cargo run. No output example package. Job all features target verbose. No, this is kind of annoying. Cargo run quiet. Okay, let's see, we have block 2 and block 1. Is there an I in there somewhere? Oh no, there's a space, that's why, okay. So we make the constraints percentage. And what is F? Let's change this to 50 and see what happens. And there. So that makes it 50. Alright, let's make it 70. So this makes the left side grow bigger. Let's change it back. And 80%, let's make it to 50. Clear, and run it again. Didn't seem to change much. Alright, what happens if I just straight up remove this? It does that, okay. But if I bring it back, the right side gets bigger, gets smaller. So if I make this like 80 before, what did I do then? Okay, so this middle part is one on the right, so it controls how much space is there, I believe. So the one is 80% left, so that one is restricting 20. Is that right? And so this takes in 10% of the screen, this takes in like 80%, and this remaining 10%. Wait, no, that doesn't make sense. What if I flip it around? Clear. And that happens, okay. What happens when I remove this again? I remove the thing at the right. Exactly. Okay, so let's change this to 10% as well. 80% makes it go to the right, so it should like shrink to the left side. Alright, so this I will change to 80. It doesn't do much. First up, I guess let's figure out what the constraint is. So yeah, constraint S still. Constraints C, where C is a vector of constraints. Okay. And a constraint is a percentage ratio or a length. In this case, it's percentage, but percentage of what? Right, let's take it. Put it together over here. Before stuff? No, before. So this is about splitting. Split. SW again. It splits an area, which is a rectangle, which is TUI layout rectangle, new area, left, right, top, bottom, union intersection, intersects with another rectangle. takes in chunks. Right, let's remove that part. And this one dot constraints versus n and 0. And where does this end? It ends here. Alright, so everything in here is still good. Right, so first off, what is chunks? So chunks is a vector of rectangle layout. This is called a raw mode terminal. That. Okay. As ref, there are 3 constraints in there. And when it's at 10%, and we have margin 1. SS. Right, that's all it gives. It's from TUI layout. Constraints and takes in the direction, so horizontal makes it left to right, vertical makes it top to bottom. Oops. Alright, it's not drawing anymore, okay. Excuse me. So this will return a split of f size. And what's this? It is a vec of rectangles. Right, so before I change, and put that in, okay. So before the changes, we got chunks 1 and we got chunks 2. So we f.render widget. So let's figure out exactly what chunks is and what's in there. Keep loaded, I guess. So it's a rectangle, and inside the rect got covered up. Okay, so okay. Let's see, it has a rect and it's here, and its x is 1, its y is 1, its width is this, its height is this, and has another rectangle. Okay, so I might not want to reprint that. Wait, I can check what it implements, right? So rect. And its trait implementations are debug. Actually, here it doesn't display. If it has debug, then maybe that's why it's all out of black, right? There you go, okay. So let's take a look at this. There are a total of 4 of them. That's normal. So we have rect 1. This. And x, which is at 19. Alright, 18, that's 1, so it's 19. This one 51. Yeah, with 18, I have 47, 47, 47. Okay. So 19 plus this is, what's this? It's a 10, 6, 7, and then it's. Yeah, 0, 1, 6, 170, 170, so I guess here. Okay. So that's what we have. Got a new line, there's a couple of things I think. About my tabs. I might not continue on this. So we've got a couple of tabs. Let's do this. Yeah, I can't go back and read it well. Okay, that's fine. Okay, so widget. So flat block equals, then let's grab that, put that statement here and make it free. Do that and make that tree as well. Actually, let's put that here. Blah, blah, blah. Alright, now we have tree on the side. And now we can really play with this. Okay. So this okay. So this will take up 80% of the screen, this will take up 10, and this will take up 10, and then we'll need 700. Not sure why I didn't see that before. Cool. Right. Template. Right. Create in just gonna do that. Really see? Let's just see. Okay. AA. Yeah, okay, there. Cross term. In Rust. Okay, there you go. Alright, let's have that for now. Alright, so this was taking up space without me knowing it. So we can probably put a couple of widgets, right? And fixing widget doesn't use a widget at all. Alright, guys. To work on my own for a bit. Is this too loud? Or I'll lower it just to be safe. Alright, let's see here. Wait, where? Wait. What do I want to look at again? Alright, okay. It's not this, it's... Okay, I want to look at widgets. Because it's going to take in 80%. I'm going to make this take in 50, so I can split this 3 ways. So what's 100 divided by 3? About 30 something, I guess. So I'm going to make this into 30%. I'm going to take this into 25. And the one is 55. 55, I need another 45. Oh, my math checks out. Yes, it does, okay. So I need this to grow a bit bigger. 45, I can drop another 15. So, that'd be 30. And this will take up the rest. So this is a total of 60, so that's 40. This should be now like a bigger one at the center, yep. And increase this by 2 and drop this into 10. And this should flatten it out, no? This takes 10%, this takes 10%, so that's gonna take... this is gonna take a total of 80. And this is 10, this is 80. We'll take up 10. So there's 20% left. So this should be 70. 80. Yeah, right, that's gonna split it up nicely. Okay. So it doesn't need to be exactly 100. So it will go from left to right. So whatever you print, you take out first. So it will fill up 100% as necessary. So whatever the last thing is that you printed out, it'll take out the rest of the space. So if I change this to 50 and put it one more time, that happens. Right, but if I do it here, then this one, right? So block 2 will have this size, block 1 will remain the same, but this will take up the rest, right? Because this only takes up 70%. Right, so this is 10%, and what's that, another 10%? Yeah, so it's going to take 10%, 10%, and it's going to fill up the rest. But A 10% thermostat field press is way more than 70 in left to right order. Okay. Okay. All right. Okay. So I gotta record this somehow. All right. Okay. Okay. So I guess this is fine. Note. Let's do that. Okay. So Kamisawa. Okay. Where was I? Right. I'd run with its stated percentage. Right. If 100% in total isn't taken, then the final block will be taking up the remaining percentage to reach 100. That's supposed to be that. Okay, cool. Did not mean to do that. Huh. Oh, who would have thunk it? Okay. So that is with percentage. So I'm gonna take this, there, and with percentage, drop that in there. And what? Cannot find value terminal in this scope. P terminal, which is a terminal and cross. It's just terminal from them. Missing generics. Cross term back end. Commented R angle. Oh, this is a mistake. Pipe is cross term back end STD out. STD out and close that. Cannot find STD out in this scope. So there is STD out and capital STD out. And there we go. Okay, let's do this. This function should return or result or option to accept this. Right. What does that do? It returns result. Okay. So that means it will return a result of nothing or an IO error. And remove that bit. Go. Right. What did I miss here? It returns an IO result of completed frame. So, okay. Well, this sure is a pain in the ass. Terminal TUI. terminal TUI. TUI terminal computer plane. Alright. Okay. Really? Oh, please. Actually, you know what? Take this, and let's just put it in here with that. That sound good? Okay, fantastic. Alright. This and take this and smash it down here. Alright, so as constraint, and I remember there's a couple up here, so let's mess with them a little. FK again, and we have ratio, length, max, and minimum. Tuple fields max. Alright, let's see. We play percentage. I'm not sure how ratio is gonna work, but let's play around with that. Alright, we have with ratio. Wait, DT that move that and do that. Okay. So here it will be ratio now. Slash s percentage ratio. That it should be right. Alright. Let's just keep it 10 for now. Let's see. And I need to run U, so with ratio. I'm gonna unwrap it. Oh yeah, no, it's gotta be faster, right? Baby. And we have ratio with absolute nonsense. Ten. Alright, let's make it all 10 for now. And mouse. And comment that out. And run it again. This 846, 546. Okay, so assuming this is x and y, right, or I mean the width and height, I mean. So the height here, it's 46 a little across the board, and its width is 0, so that means it's a little too big, right? So first, let's start increasing this to, let's say, 50. Right, with it increasing to 50, not much changed. Okay, let's try increasing both to 50. Let me do that. And converting both to 50 changes nothing as well. Alright. How about we skew one side? Okay. So this is the X, and I assume this is the Y. So this is enough space, so let's bring this down again and then see what changes. Oh, if I increase this to past 50, that's for 71, it makes it smaller. Okay, so let's call it ratio XY. Actually, if you call it AB. Okay, let's do ratio AB for now. So, right, so if B controls the width, then that A controls the height, right? Like if I, yeah, what's that do? Oh wait, I can do this. Cargo R. Right. Now let's make this smaller. Run it. Same length though. Let's see if this splits it better. No, it's the same length. Okay, so what does A control? 6, 2, and 4. Well, it's separating, so it's good for now. 2, 4, 2, 4, so this takes up equal mono ratio. I'm gonna reduce this and mix and match. Alright, I guess there's not much point in playing with ratios. We got the length, which I assume is the pixel size. Length. There you go. Gonna get rid of that. And pre-treat and it'll fill up literally the rest. Okay. So how wide is this thing? Alright, b Python x equals this. 1, 2, 3, 1, 2, 3, then x. 190. Okay. So 190, I divided into 3 equal portions, so that is... It's 9. 3, 3, 9, 3, 5, 15, 6. 6, 38, 18, 18, 33, 33. Okay. So 33, 33, 33. And, alright. It takes in 33, it takes in 33, and it takes in another 33. Okay, 190除3，13、35、35、6、38、13、21、6、38、19、18、10、6、6、33。Okay. 6, 6, 6. Alright, 63, 63, 63. And they should be like more or less equal. Yeah, it's more or less equal. Probably you just split a little bit. Yeah, there you go. It's practically the same. Okay. Thanks. There you go. Yeah, okay, this is self-explanatory. Okay, so I can either work with percentage or I can work with like. Okay. What else I want to plan it for tonight? Hold on. I plan to do implementing a binary tree. That way, that's something that's on my list. Sure. Okay. Let's take a look at all the stuff first. Not sure what I changed, but take right. Alright, let's start up everything. And let's restart it, why not? Wiki, yeah, binary. Let's figure out the definition of binary tree in the first place. Okay, yeah. Maybe I can try with something without saying. T1 and T2 extended binary tree denote by T1 T dot T2 by adding a root R connected to T1 and T2. Where did the R go in? What? Okay, that probably isn't. So what is it? What's other Python? Well, I guess either way is fine. What's in here? Uh, binary tree.com. Free. Here we go. Okay. Alright. Right, go to go itself, and then I guess some value. Let's give it none for now. Self dot root, self dot left, and self dot right. None. Trees. Using arrays and using linked lists to all linear structures that you have to different. Linear strings, arrays with stacks and queues, or most of them. These are used to mainly represent data hierarchical. Fine. Set E one more nodes such that there is a node that designated as the root of the tree and the other nodes are divided into n greater or equal to 0 disjoint sets. Oh, this is joint means again. That means intersection, right? Yeah. T1, T2, and fault T, and I called subtrees or children for brain. It's a binary brain, right? A binary tree is a special type of tree in which every node of vertex has either no child, where every node of vertex has either no child node, or one child node or two. That can be 0, 1, or 2. Binary tree is an important class of tree data structure in which it knows two. Left child, alright, makes sense. And term is right, okay, figure mentioned below. Root node has 8 has 2 children, tree 10, that is 6. Okay. Binary tree is either an empty tree or a binary tree called the root node, the left subtree and the right subtree. So I guess let's fill stuff out. Okay, so it can either have a left or a right, which is that stuff. So, and then the left can either have a left or a right. Okay. Will contain binary tree. So we have left and we have right. So none left, right. Let's do that. Okay. So tree equals binary tree, and a binary tree can either have something or it can have nothing. Yep, so what the hell do I do there? Okay. I think let's give it none for now. Okay. Right, let's insert the stick in the left and the stick in the right. And then we have none and we check none. Okay. So let's go from left to right. If self.left equals none, then we go do something. If not, then self.right equals something. I should probably continue reading it. Yeah, so you gotta fill in the left side first. If you fill in the left side, you're gonna keep putting things in. So it should be value instead, right? Put in value. Alright, value can be anything. So then what's gonna happen is that it's gonna call, so self.left will be equal to a binary tree. And what is a subtree? And if right, so this will have self.left dot self.left, so it will need to keep going. So I'll need some kind of loop. So while left is equals to none of figure. Okay, well left is not equal to none. Do that for now. Okay, what do I do if left is equal to none? So if it's empty, it will just stop immediately. So I need this to be equal to none. So if left, okay, if left is equal to none, then I need to insert it to the left, right? So then this will be subtree. Okay. And then what I need to do next. Wait, what's the title for this screen? I just realized. Oh, hello. Yeah, sorry, I wasn't on the right screen to see your message. Oh, I'm using Rust. Hmm. Alright. So I have a subtree which I need to call insert. So wait, no, I need to keep calling next to figure stuff out. Okay. Hold on. So the root node would have wait, hold on. Okay, so the root node will contain itself a left child or a right child. So really, it should be like this. DT do that, bring that here, get rid of that. Okay. Okay, it's self.root. So let current that. Okay, well current is equal none. Right, so self dot, and then I'll need run this in okay, self dot right, so they can contain something. Okay, So while it is none, I need to first look at the left side. Yeah, I need to look at the left. So current dot. Yeah, doesn't make sense. Okay, so this has to be another binary tree. And the binary tree will do that. Okay. Let's think about what will happen if the binary tree constructor is called again. So just keep repeating on infinitely. Right, self-storage is a binary tree, and it goes inside. So, okay. So binary tree, it gets inside here, it sees the end, it calls here, it gets inside here again. Alright, that's not helpful. Alright, let's take a look at what happens. Yeah, recursion depth, got it. Okay. So it can either be none. So I need something self.head. Okay, if self.head is equal to none, then self.head equals binary tree. So this will give it the node. So current equals self.head. Okay. And now current will have access to left as well. So while current is not equal to none, right? Then I'll need to do current dot left. If current left is equal to none, then current dot left will equal to value. Right? Else current dot right is equal to value. What is this? Oh, it's Celeste. Okay, else if elif current dot left is not equal to none, and current dot right is not equal to none, then current will be self dot head. Okay, current will be current dot head, and I can grab that. Okay, and current is equals to current dot head. Does that even make sense? Binary tree. Alright, so far so good. Binary tree dot insert. Let's go to 1 and 2. Alright. Tree. F dot tree equals, wait, tree dot insert. Okay. Print tree dot underscore dict. This is a variable. So it has head. Which is a binary tree object. And what is inside a binary tree? It has self.none and self.right. Okay. So that display, I guess I should call this print. It's gonna take itself. Okay. So what it's gonna do is it's gonna traverse, so go left, right, left, right, left, right. And I want to group them into a tuple each. So yeah, so it's gonna go left, right, left, right, left, right. So let's see. It's gonna go left, right, left, right, left, right, and it's gonna travel down the thing. So current equals self.head. Right. If current equals none, then print empty. Okay, tree is empty. Okay, so we'll move on. So while current is not equal to none, right? We will take current dot left and current dot right. If current dot left not equal to none, else if elif current dot left not equal to none as well, move that in for pass and for pass. Okay. So here we'll put results, which is this. So then what we'll do is results dot append left right equals none. Left equals current dot left. Right equals current dot right. Let's do that for now. Okay. So over here, result dot append left right. Gonna keep going. Here's just the else for now. And let's yank this. Elif current dot left not equals to none. And we have this stuff. Then what I'll do is current dot head equals current dot head. Is the indentation wrong? It feels kind of off. Indent in, indented in, indented in, indented in, indented in. Okay. Let's see. Right. So here, left, right, I gotta reset it to none. And print. Non-iterable. Cannot unpack non-iterable object. Oh. Right. So put one none, okay? And still one none. Alright, let's go through this step by step. And I'm gonna move this up. There we go, okay. So I have insert. It's gonna take a look at self.head. Right, and it's gonna be none. Right, we call insert the first time. It's gonna be none. Gonna head up here to if self.hit, right? It's gonna call binary tree. Right, so now it's not none. Well, current equals self.head. Well, current is not none, so it goes through current.left. Right, current.left is none. Current.left.value. Right, it will be equal to value. And current equal to the head. Right, and current.head is the binary tree. Right? So since this is the tree, then what happens exactly? It becomes a binary tree. It gets filled with this stuff. And current will not be none. we'll go to look at right, right? Right, so it's not none anymore because there's something inside it. And this part isn't true, the rest isn't true because it's none. So come over here. Right, if you'll come over here, then we'll insert it. Right, it's still hit, it's gonna go through again. And what happens after I go through it? It's gonna come back out here. Break. 3.dict head. What's inside it? We got head. Right, so left and right should have something in there by now. Okay, so this is wrong. So when it's inserting, I want it to go to the left, right? So if stuff, wait, current dot left is equal to none, then current dot left will be equal to something else, right? Right, simple as that. All right, infinite loop. Okay, so I better figure out how to stop it. Since current dot left already has something in it, with current, what exactly is current dot left? It is none. So now it has a number in it. So I know I'm missing a piece here. Let's see, current dot left will be equal to value. Oh. Okay, current dot left. So this is right. This was true. Okay, so this is true, and now it's false. But this is still true. If this, that means gonna put an and in here, so this will no longer be an infinite loop. So print tree dot dict. This dictionary with head. What's inside head? Right, so now it has left is none, right is none. Alright, let's see. Open genus IQ. Basics implementation traversal search deletion operation. Data left, data right, data left. Everybody what it means. Okay, let's read. It is 9:33. Oh, looks like I gotta go stop soon, or I won't be able to go to bed earlier tonight. Oh, got a few new followers. Thank you for following. Sorry if I also is are um Zach Fear. Are you like the guy on Discord? No, I think you are. Sorry for not responding. I was in like a completely different screen on my second monitor, and I didn't see the chat message at all. I'm sorry about that. Okay. So let me stop that for a second. So thank you to everyone who has joined me tonight. Okay. So who knows what I'm gonna stream next? Got revisions to do. Anyways, thank you all for joining tonight. Those who have joined, whether you're lurking or not. So yeah, thank you, and I'll see you guys in the next stream. Bye bye.